Hey guys, welcome. In this video, I'm going to teach you how to avoid memorizing the unit circle and instead learn it through the 30, 60, 90 and the 45, 45, 90 degree triangles here and here. Yeah? Cool. Now, to get started, in my labeled unit circle, I'm going to draw a bunch of reference triangles. You should know what reference triangles mean from previous lessons. So here's a reference triangle for the 45 degree angle in the first quadrant, and it's going to look like, well, sorry guys, let me draw in blue, like that. Let me draw a reference triangle for the 30 degree angle in the first quadrant, which will look like this. Let's draw another one for 150 degrees. One for 135. In a different video, I'm going to teach you how to remember the angles around the unit circle, these important angles, but it's fairly straightforward. So I'll do it where I show you how to remember them in radians, but it'll be a short video. Cool. Alright, now these are enough reference triangles. Obviously my circle isn't perfect, as you can see from that, but it's okay, we'll live. And of course, since we create reference triangles by dropping perpendiculars to the x-axis, these are right angles here and there, and likewise here, here, and here. Now also note that this reference angle is 45 degrees, and therefore this blue triangle, or at least two sides being blue in the fourth quadrant here, the third side is clearly that, so that triangle is a 45, 45, 90, as is clearly the 45 degree angle reference triangle here. So this is 45, and likewise here, and then we've got 60 degrees here, and we've got 60 degrees here. And let me draw actually one last additional reference triangle, and it's for the 60 degree angle in the first quadrant, and its reference triangle will look like this. Yeah? Okay, now this clearly is going to be 30 degrees. And since we're on a unit circle, all of the reference triangles have a hypotenuse of 1, because the hypotenuses of every reference triangle we draw for all of these angles here is going to be the radius of the circle, and therefore, since our circle is a unit circle, all of the hypotenuses will be 1. Additionally, notice that every reference triangle we draw for any of the labeled angles is going to either be about the 30, 60, 90 degree triangle or the 45, 45, 90 degree triangle. In other words, every reference triangle for these labeled angles is either a 30, 60, 90 or a 45, 45, 90, except for the quadrantal angles, which are like this, 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 and this, but those are fairly easy to figure out, right? They're coordinates anyway, right? Okay, cool. Alright, now, first, let's notice that, you know, if we take the reference triangle for 30 and compare it to the reference triangle for 150, they're the same triangle, right? One is a mirror image of the other over the y-axis here, right? This vertical axis in the middle. So then all that will change is that the reference triangle for 30 will have x and y coordinates that are positive, whereas the reference triangle for 150 will have a negative x coordinate, because x is in the negative there, but the same y coordinate as 30. And in fact, the actual numbers will be the same both for 150 and 30. It's just that the x coordinates will be negatives of one another. Yeah? Cool. Additionally, if we look at this reference triangle for 30 again and compare it this time to the reference triangle for 60, we observe that we just swap the x and y coordinates, because for the 30 degree triangle, or the 30 degree reference triangle anyway, the x coordinate is going to be the longer leg of the 30, 60, 90 degree triangle. But for the 60, the x coordinate will be the shorter leg, and it will be the y coordinate that will be the longer leg. So we expect that the coordinates of the 30 degree angle and the 60 degree angle would just be swaps of the x and y coordinates. That's fairly easy to see. Okay, cool. With all of this, I guess we can now, solve for the actual sides of these triangles using this and this. And of course, to solve, what we require is that the hypotenuses be equal to 1. Because on a unit circle, all of the hypotenuses of every reference triangle is going to be 1. So setting this equal to 1 and setting this equal to 1, it's easy to see that a has to be a half, and therefore a root 3 will have to be root 3 over 2. And then here, we see that a root 2 equals 1 will mean that a is equal to 1 over root 2, which when we rationalize it, will read root 2 over 2. So this is root 2 over 2, and this is root 2 over 2. And notice that on every reference triangle, the horizontal distance is the x coordinate. And so this is going to be x, and this is going to be y, and likewise here. This is x, and this is y. Yeah, cool. All right, so I think we're ready to label our unit circle now. Let's start with the easier ones. Here, it's going to be 1, 0, right? Okay, cool. That's easy to see. Let me actually do this in what color? What color is, I guess, red. So here it's 1, 0. And for the 30, we see that the y coordinate is a shorter leg, and therefore 1/2, the shorter leg of the 30, 60, 90, clearly, right? So the y coordinate is 1/2, and the x coordinate, the longer leg, is root 3 over 2. Got it. And so then we could label this one now, because we said it's just that the x will be negative, so negative root 3 over 2, and then 1/2, the y coordinates are the same, and then the 45 degree angle is fairly easy. X and y coordinates are the same, and 60 we said is a swap of the 30, so 1/2 and root 3 over 2. 90 is 0, 1, and that's easy. 120 here, although we didn't draw the reference triangle right here, will be exactly like 60. It's just that the x's will be the negatives of one another, so it's just the same as this. It's just x is negative, so negative 1/2, and then comma root 3 over 2. This x is negative, but negative root 2 over 2 and root 2 over 2, just like over here. So let's skip around. What about 225? It's like the 45, 45, 90 right there, right? Yeah, so that's going to be root 2 over 2 and root 2 over 2, but this time both x and y are negative. So x is negative and y is negative. So negative root 2 over 2, and then negative root 2 over 2. And what about 300? So this is the same as over here, except y is negative. So 1/2, and then negative root 3 over 2. Okay, cool, there we are. And obviously I think at this point you know how to complete it, and I'm not gonna bother actually filling in the other parts. You can fill that out. But you must be asking before I sign off, why do we care, right? The reason why we care is because now you know that on a unit circle, since cosine of theta is equal to x and sine of theta is equal to y, why did I write 10? I don't know. Sine of theta is equal to y, because we know these things to be true. You can readily find the sine and cosine of all of the labeled angles. For example, cosine of, cosine of 150 degrees will have to be, well, we just said cosine is x. So we go to 150, look at the x coordinate, root 3 over 2. So root 3 over 2. How about one more? What about sine of 315 degrees? Well, 315 is the 45, 45, 90 reference triangle where x is positive and y is negative. So let's fill that out. Root 2 over 2. It's 45, 45, 90, my bad. Root 2 over 2, and then we just said y is negative, x is positive. So that's positive, and then negative root 2 over 2, y is negative, and sine is y. So it's just the y coordinate here, which is negative root 2 over 2. So this is why we care, yeah? Cool. Alright, I'll have a couple of additional videos on the unit circle to complete your understanding of it, but I hope this goes a long way. Take care.